Alrighty, last video we talked about just kind of basics. We talked about basics, like very, very basic stuff about the quadratic functions, specifically what we see on the formula chart, and then we reviewed what we knew about linear functions. Now we're going to jump into actual quadratic functions. So quadratic functions are functions that contain x squared. Okay, this is, find a highlighter that I can actually highlight with. This is really important because it's going to have x squared. Now, it doesn't mean that it just has x squared in it, because this, for example, x to the third plus 2x squared plus x minus 1, this is not quadratic, okay? Let me just hold that up. That is not quadratic, because even though it has a squared variable, it's not the highest exponent. So it can't just have x squared, it's got to be the highest exponent that you see, the highest positive exponent that you see. Okay, so we'll talk a little bit more about positive and negative exponents when we get to Unit 6, but for now, what I need you to know is that, like, if it was just, so if the x to the third wasn't there, then this would definitely be a quadratic function, because the highest exponent I see, the highest thing I see is x squared. All right, so really that's all we're adding. You know, before when we did linear functions, we had 2x plus 5, now we're maybe saying 3x squared plus 2x plus 5. So we're adding another type of term, which we're going to talk about in a minute here. So again, just like the linear parent function, we have a quadratic parent function. It's that simplest quadratic function, and it is f of x equals x squared or y equals x squared. Okay, this is our parent function. Okay, so that is the simplest quadratic function we can write. And if you recall, when we looked at the formula chart, we can get a little crazy here. We can add an a, which does some stuff. We can put in h and k, and that tells us something too. Okay, and again, we'll talk about that, you know, soon. I don't want you to get overwhelmed with stuff. Okay, so this is our simplest simplest quadratic function that we can write. The parabola, and it's pronounced parabola. So I mean, don't be saying parabola. That sounds like Ebola, and this is not. We don't even put that energy out here right now. So it's did I just say parabola? Oh my gosh, seriously, y'all got me all, it's got me all twisted. No, don't write what I wrote. La. I literally just almost wrote parabola. Wow. Whew. Been a long break. Okay, so parabola. That's how you say it. Don't say parabola. Oh my gosh, I gotta stop saying it or else I'm gonna keep saying it. Okay. So when we talk about a quadratic function, okay, we also have different parts of that function, and we are really going to hit on those points in a couple of days, but I want you to know what they are. So remember we had talked about like key features, and the key features in a linear function were the slope, the y-intercept, the x-intercept, which is 0, and the actual equation. Well, we have even more key features right here. These are our key features, which we're going to talk about in the next video, are key features of quadratic functions. So those key features are the minimum or maximum point of a parabola, which is called the vertex. So this, if it's pointing up, it's got a minimum because it's the smallest point. If it's pointing down, it's got a maximum. Okay, so vertex and min or max are kind of also key features, but the vertex is that point where it turns around. Okay, the axis of symmetry is a line that goes right through it. And yesterday we talked about, well, in the last video we talked about how, like, the linear parent function kind of creates an axis of symmetry. Well, an axis of symmetry, remember, is, and just pretend this is square, is if I take something and I fold it in half. So like if I have my hands like this, I fold one hand over the other, they're symmetrical, basically. Okay, so like a heart is symmetrical. So like, for example, if I look at a heart right here, assuming I drew that correctly, that line that I could put down the middle of something to fold it in half and have perfect symmetry, that's what the axis of symmetry is. And our parabolas do have symmetry. Their symmetry goes through the vertex, and you could fold them in half. We'll talk about that too. Symmetrical points are pairs that are on opposite sides of the parabola. They have the same y values. The x-intercept is the point where that parabola crosses the y-axis. And the x-intercept is where it crosses the x-axis. Now we called it 0 a lot in the last unit, and y'all were like, what's a 0? Okay, look, zeros are everything in quadratics, okay? So you have to understand, they will ask you about zeros. And just like slope had like a billion words, 0 has a bunch of words that mean, that are synonymous with it too. Okay, so that's our vocabulary. That's our quadratic vocabulary.